Hello and welcome back to Rotary Rockets. If you follow our channel, you may have seen the last video we posted a few weeks ago. We had our 1,000 subscriber special, and for that we launched our brand new homemade Assassin 1 rocket. It was a very successful launch. We had a couple little problems. We're going to work through those. Now in this video, I'm going to show the entire build process for this entire rocket from start to finish. Now this is one of our longer videos, so there's chapter markers down in the timeline if you want to jump around to see just some specifics about maybe how we install the fins or vent holes or something about the flight computer or the nose cone. You can jump around easily using those chapter markers. Let's go build a rocket.
I started out by designing the rocket in the OpenRocket software. This is a free piece of software that makes it really easy to design a rocket and also check to see if the design is stable. For some of the parts, I knew the exact weight, like the body tubes and a few other items. So as I was putting those parts onto the rocket design, I put in the accurate weights for those items. Some other pieces I don't know the exact weight, so I just estimated, such as the nose cone. That's going to be a 3D printed nose cone. So after that's printed, I'll come back in and I'll put in the proper weight for that. And the fins also, they're going to be cut out of 1/4 inch MDF, and when those are cut out, I'll weigh them and come back and enter in the proper weight for those. That way I can continue to check that the rocket design is stable. Now, I also took the data from our ground test for our motor that we're going to be using in this. I put all the data in so I would get a thrust curve for that motor. Now, this is really just an estimate because our test stand isn't all that incredibly accurate, but it gives me a little bit of data to work with so I can actually do a simulated flight in the software. Next, I went over to TinkerCAD and I made the fin layout. This will be exported so that we can cut this out on our CNC machine. It's going to be made out of 1/4 inch MDF. And then also, again in TinkerCAD, I designed the nose cone, which will be 3D printed out of plastic. Here's the first fin. We just need to cut out 3 more. I built this little jig so that I could file a pointy edge on the leading edge of all the fins. Here I'm making a fin alignment jig. This is just a simple tool that's going to help me hold all the fins in place while they're being glued in. That came out really nice. So the 3-inch cardboard tube simply fits onto there, and this will allow us to hold the fins in place when we get to installing the fins so that the glue can dry with the fins aligned properly. I've cut off a piece of our 3-inch cardboard shipping tube. This will be the lower section of the rocket for the fins and the motor mount. So I'll go ahead and use the fin alignment tool just to mark the location of all 4 of the fins. I've extended each one of those lines up the body tube, and then I'll just use a fin as a guide to make marks on that line to show where we need to cut the slot in order to fit that fin tab into the body. To make the slots, I'm going to start out by drilling a 1/4 inch hole at the bottom mark on each one of those lines. And then to actually cut the slots, I'm going to use this 1/4 inch bit. Now this is commonly called a rotozip bit or an X bit. It looks like a drill bit, but it's made to cut on the side. So I've set one of these holes up into that rotozip bit and then set the table up underneath this. Now I've shown this before on another video and I've said it before, but I'll say it again. These bits are really aggressive.
it is very easy for this bit to just grab this piece and just spin it out of your hands, or just cut a violent slot through the cardboard. So you have to hold on really well with this. Watch where your hands are. Don't stick your hands inside where the drill bit is. Just follow it down the slot. Definitely, if you've never used one of these bits to do this before, get a test piece of cardboard, make a nice straight line, or maybe a couple lines, and test this out first. It takes a little bit of practice to get it just right. Got all 4 done. Now on the outside it's not too bad. I'm just going to take some sandpaper and clean up these edges here. But what you will notice on the inside is where most of the mess is. I do have to get rid of all that frayed cardboard in there because that's where the fin backers are going to be glued in, and I need a good surface in there. So I'm going to get in there with some sandpaper and clean all that off. I usually start out on the inside with 60 grit because it's just really difficult to get all that large clumps of cardboard off. So here's another example of why building a 3-inch diameter rocket is a little bit more difficult than building a 4-inch diameter rocket. So I got my 60 grit sandpaper and tried to sand the inside of the body tube. It became evident that I was only going to be able to get down just a couple of inches, and I need to get down quite a ways. So what I ended up doing was taking a piece of PVC pipe and just using some duct tape to attach some 60 grit sandpaper. And that seems to work well for sanding the inside of those slots. Now that I've got those cleaned up inside and out, I'm just going to test fit all 4 of the fins to make sure that they fit good in the slot, and make sure that the bottom of the fins line up with the bottom of the body tube. If I need to sand any of the edges or sand it so that it's a little bit longer on either end, now's the time to get that fin fitting perfectly. I've used the CNC machine to cut out a few more parts for the fin installation. So these first pieces are just little 1/2 inch by 1/2 inch MDF pieces with a 1/4 inch wide by 1/4 inch deep slot cut down the center of it. Now the way I install the fins is this fin tab goes into the slot, and then just align it with the bottom of the tube for this particular design. And you see the fin tab sticks into the rocket body about 1/4 inch. And that's where these fin backers go. They get glued onto that tab just like that. And for this particular design, I'm going to have one backer glued onto the bottom of that tab, just even with the bottom, and another one at the top, just even with the top of that tab. Now the glue I'm going to use to attach these little backer pieces is construction adhesive. Now you could also use wood glue or 2-part epoxy. The problem with wood glue and 2-part epoxy is they have a fairly short working time and they're runny. And I don't want to take the chance of the glue running down away from the pieces that I want it to be on and dripping down the tube and possibly even gluing my tube to my alignment tool. So I don't want any kind of glue that's going to be runny, especially where it's inside where I can't see what's going on while it's all setting up. So the construction adhesive is a good solution. It has a long working time and it's a nice thick glue that doesn't run at all. So I'm going to go ahead and get these fins installed and then we'll move on to the next step. Got all the fins on and all the backers in place. So let's go ahead and get that set into the jig so that it can dry. Now this construction adhesive says it takes 24 hours to dry, so I'm not going to rush this. I'm going to let this set for an entire day and we'll come back and continue it later. The adhesive is all dry on those fins, so we're ready to move on to the next step, and that's these 2 pieces here. Now these 2 are identical. It's just a piece of 1/4 inch MDF. I machined this out on the CNC machine. You see on this side it has 4 little indents as well. Now these serve a couple of functions. First off, it's a motor centering ring, so the motor tube fits nicely inside there. Secondly, they're what I call a fin binder ring. So if we look on the bottom
the body tube here. Inside, we see we've got the 4 fins that stick in and those backers that are glued on there. That's why this has those 4 little indents. This is going to get glued in there on top of those little backer pieces. So we'll put adhesive on the backers, we'll put adhesive on this piece, and also adhesive around the cardboard tube so that this gets completely glued in place. And what that does is it binds all the fins together. So if one moves, they all have to move. And right now, without anything like that, you can see that the fin is wobbly. It's easy to move because there's really not a lot supporting it with the way that it's installed. This will bind them all together and they'll be extremely rigid. So right now I'm going to go ahead and get the bottom one glued in place. I've got that ring installed and I gave that glue a little bit of time to harden up. And now I'll go ahead and do the same thing on the top. This one's a little trickier because it's way down inside the tube, but I'll just use some sticks to get the glue down there and we'll get that glued in place. So just a quick note, I was test fitting this in, and what I was finding was it was difficult to get it down in there and get it to fit over all 4 of the fin backers, just because there's no way to get your hand down in there and work with it. So I made these slots about 1/8 of an inch wider just using a bit on the Dremel tool, and then I test fitted that in, and it's a lot easier now to get it to fit in place. Also, there's just little lumps of glue that are down on those fin backers just from the gluing process, and having this a little bit extra wider was making it easier to get it over all that. Now that I've got that top binder piece installed and the glue is set up, the only thing left to do on this fin base is to install fillets, which is just a filler or adhesive that goes in that transition between the fin and the body tube. That seals up any gaps that may be in that slot that we cut, and also gives a nice smooth transition between the 2 materials. Now, 2-part epoxy, a 5-minute fast drying epoxy, is a good material to use for those fillets, but because it is a runny type of adhesive, you have to do 2 fillets here and let that set for about 10 minutes before you can rotate it and do the next 2. So again, I'm going to use construction adhesive similar to what we've been using on the rest of the parts here for the fins. But I did notice something unusual that happened on the last rocket build that I did when I used construction adhesive for the fillets. So I did a little test just to see what actually happened there. And I just took a little piece of wood, glued it down to another piece of wood. And I installed a fillet on this side just by putting some of the same construction adhesive in that gap and then running my finger down it. And then I used a different construction adhesive, did it on the other side, and same thing, just ran my finger down that just to smooth that out. And what I noticed is that this particular brown PL style of construction adhesive seems to expand a little bit when it dries. When I ran my finger down it when it was wet, it was perfectly smooth, made a nice transition between the 2 pieces, but it kind of expanded a little bit as it cured. And you can visibly see that it's just a little bit bumpy, and when you run your fingernail down across it, you can actually feel the little bumps. Maybe you can see that. So on the other side, I used this, it's also a construction adhesive, just same company, different type of adhesive. This one happens to be white. And I did the same thing on the other side, and it came out very nice. It basically looks exactly the same as what it looked like when it was wet. It didn't expand, it doesn't have any bumps, it's nice and smooth. Now, I know those little tiny bumps may seem very insignificant, but I am going for a very smooth finish on the outside of this rocket. So I want to use every method I have available to me to get it as smooth as possible. So I'm simply going to use this type of construction adhesive for those fillets. So I'm going to go ahead and do all 8. Since this doesn't run, I can do all 8 of them and then just let this set overnight and let that adhesive harden. I've cut out another section of the 3-inch cardboard shipping tube. That's going to be the top section of the rocket body. Then to join those 2 together, I've cut out a short piece, 4-inch long piece of the shipping tube.
I calculated that I need to remove approximately 1/2 inch of that tube. So I'll cut down each of those lines. That will allow this to squeeze a little bit smaller and fit into the 3-inch shipping tube. And I've also marked a line all the way around the center here so that when I do put it in, I know I've got half of it in this tube and half of it in the other tube. I've got that little section cut out of the coupling tube. When you pinch that closed, it fits very nicely into the cardboard shipping tube. So I'm going to go ahead and use the same construction adhesive that I was using on the fins. I'll glue that into this tube and then I'll glue this section onto the bottom tube. So this is finally looking like a rocket. We put the nose cone on the top here. That's our final shape and size. The only part that's left to get mounted inside this body tube is the mounting point for the parachute cord. Now the parachute cord is just going to get attached to a little eye bolt, but we need a mounting point inside the rocket for that. So I've got here a little PVC cap, and normally we would look for a cap that fits nicely inside the 3-inch shipping tube. Unfortunately, I was not able to find any kind of PVC or ABS cap that fits perfectly there. This is a 2-inch cap, and it's about 1/4 inch loose inside that 3-inch tube. So what I'm going to do is 3D print a little spacer ring that fits nicely onto this cap and then also fits snugly down into the body tube. So we'll get this eye bolt attached onto here. We'll get a section of paracord attached onto this. That will get slid down into the body tube, and we'll slide it all the way down until it hits that little cardboard tube that we have inside to join the top to the bottom. That'll be the stop for this. And then we'll have 4 little screws on the outside of the body tube that hold that in place. Here's the finished part. I glued the ring to the PVC cap, and I also cut off a section of the PVC cap because we just didn't need it that long, and that gets rid of a little bit of weight. I'm going to attach the paracord to that and go ahead and install this in the rocket. I've got that ring installed. The screws are nice and tight. Now I'm going to do some vent holes for the body tube. Now the vent holes are to equalize the pressure between the outside of the tube and the inside of the tube. It's not really important to the rocket, but it is important to the flight computer. And so our flight computer is up here in the nose cone area, and it's got vent holes that vent it down into the inside of the top of this tube. So we need to have holes in this tube so that we know that the air pressure outside, the air pressure inside, and the air pressure around the flight computer are all the same so that the flight computer can properly detect the altitude. So I've just got a little 5/32 drill bit here. I'm going to measure up from these screws about 2 inches and put a set of 4 holes in the tube there. And then I'll measure up about another 8 inches and put another set of 4 holes there. Now, this exterior finish is going to be a thin coat of epoxy coating, and that epoxy is probably going to clog or at least reduce the diameter of these holes that we're going to drill. And that's okay. After the finish is all done, I'll come back and I'll hit all those holes again with the drill bit just to open them back up to that 5/32 size that I want. Now sometimes when you drill holes through cardboard like that, instead of drilling a nice clean hole through, on the inside it kind of pushes in a little bit of the cardboard. So if you could see down inside, you'll see at each one of those holes there's just like this little bump of cardboard around each hole. Now I really need to be sure that these holes don't get reclogged either from adhesive or from the epoxy or even just from the parachute going in and pushing some of that cardboard back against the hole. We need to have good open vent holes. So just like we did when we had to clean up the cardboard on the inside of the tube for the fin slots, I took a little piece of sandpaper and taped it to a piece of PVC pipe. And I'm just going to come down from the top and run that down around each one of the inside of those holes just to clean up those holes to make sure that they're nicely opened and don't have any chance of getting blocked in the future. Now, I want to give you a quick update on the vent holes. Now, we were further along in the construction process and we test fitted the parachute in here, and what we noticed is that the parachute tended to block off a couple of the vent holes. We really didn't like that. So what I did is I went back and I enlarged the 8 vent holes that we already have. We enlarged those to 3/16 of an inch. They're just a little bit bigger than what they were before. And then up here closer towards the top of the rocket body, we drilled another set of 4 vent holes as well. So we've got a total of 12 vent holes, 3/16 of an inch. So even though some of those might get blocked off by the parachute, I think there'll be enough venting in there to allow the flight computer that's in the nose cone to get the information it needs to determine the proper pressures. Exterior finish time. So I'm going to start out with a couple of coats of spray paint. We're going to prime it first and then gloss black. Now just a note, I did take out this parachute mounting point from inside of the rocket body. I didn't want those screws to get sealed in the paint and the epoxy that we're going to put on later on, just in case this needs to get removed. So I'll set that aside and we're ready for painting. So the paint job is done. It came out really nice. Now we're going to go ahead and put on a coat of 2-part epoxy. This is a slow drying epoxy. It takes a couple of days to dry. So why are we putting epoxy on the rocket? It is going to add a little bit of weight to the rocket, but that's okay. It's going to help to strengthen the tube a little bit. We also want a super smooth finish on this rocket, and that's what the epoxy is going to do for us.
And now it's time to 3D print the nose cone.
I just finished painting the nose cone. After I painted the nose cone, I was starting to move on to some other parts of building, and a major problem occurred to me about this current design. So let's take a look at the problem and the solution I came up with. On our current model of 4-inch rocket that we've been using for a very long time, we have this threaded cap piece here where the flight computer, the battery, the parachute cord, and the ejection charge are all attached. On the launch pad, just before we launch, we activate this flight computer, and it just gets put down into the rocket body and screwed into a threaded insert that's inside the rocket body. Because it's a 4-inch diameter, there's plenty of room to do that. So that's not really a problem, but it occurred to me that we're going to a 3-inch diameter tube, and that is a problem. Now I could force my hand in there, but I wouldn't be able to get down far enough to even thread in something similar to this that far down in the rocket. So that's a problem as far as installing and activating the flight computer. So I went ahead and printed another nose cone. Now at first glance they look identical because on the outside they are identical, and I will paint this one red a little bit later because that's the color I want. This one has a large opening in the bottom with threads on the bottom as well. And that's where this little piece comes in. This threads into the bottom of the nose cone. Now this piece has several functions. So first off, you see it has a little eye bolt here for attaching the parachute cord to the nose cone. Also on the bottom, there's a little hole here, and that's where our ejection charge goes. Now we make our ejection charge using these little 1/2-inch CPVC plumbing caps. The only thing is that it's just been cut in half so that it's not a very deep cap. That simply sits in that little indent there, and then there's a little retaining clip that goes on, it screws on over here to hold that in place. That will be facing this direction, so the ejection charge faces down into the rocket body tube. So on the other side here, the section that goes into the nose cone, we've got 4 little mounting holes. That will be where the flight computer mounts onto this. And then there's a little area right here for the battery to sit into, and then we'll just put a couple of dabs of hot melt glue to hold the battery in place. Also, we've got these 2 large holes on the left and the right here. These are just vent holes so that we don't get any pressure difference between this chamber here where the flight computer is and the bottom section of the rocket. We need to get the pressure to be the same because the bottom section of the rocket will also have holes drilled in it so that it equalizes to the pressure of the outside. That way everything will be the same pressure and the flight computer will be able to determine the altitude. We're going to go ahead and get the flight computer ordered real soon, and we'll get that installed. I'll show this piece when we get that all installed and how that fits nicely up into the nose cone. The flight computer showed up, so let's open it up and have a look. This is the Eggtimer Apogee flight computer. As you can see, it's a kit. You do have to put it together yourself. It's not very difficult, just requires some basic soldering skills. We've used the Eggtimer Apogee flight computer on several launches already. It's proven itself to be a very nice and effective flight computer. It's also a very inexpensive and probably the least expensive flight computer that you're going to find on the market. And that makes it good for experimental rocketry, especially when you're not really sure what's going to happen with an experimental rocket or an experimental motor. Now, this serves two functions. Number one, it will beep out a sequence of beeps at the end of the launch to identify how high your rocket went. And number two, and more importantly, when the rocket reaches apogee, it will fire an ejection charge that will pop out your nose cone and eject your parachute. Now, in this video, I'm not going to show the whole process of assembling this circuit and testing it. I've already done that and posted a video quite a while back about that. If you want to take a look at that, there'll be a link down in the description to that. I'm just going to go ahead and assemble this now, and then once we get it assembled, we'll be able to mount that onto the bottom of our nose cone base. I assembled the flight computer and I tested it. And that's the finished electronics bay. Now, the only thing left to do on this before launch is install the ejection charge, and that will be in this little cup here that simply fits into the little opening back here. This retaining clip swings around and down. That gets tightened in place. And that will be the ejection charge securely held into that piece. And then let me just get these wires out of the way for the moment. This whole thing screws into the bottom of the nose cone and it's ready for launch. I want to give you a quick update. We had our launch and we did have some damage to this piece that screws into the bottom of the nose cone. It seems that when the parachute ejected and deployed, the stress of pulling on this eye bolt was just too much for this piece and it simply ripped apart. Now, this was a 3D printed part and it only had a 10% infill, so it was mostly a hollow piece and clearly not strong enough. So I've made a couple of changes for the next launch. This piece here is solid, it's 100% infill, so it's substantially stronger. Also, where the eye bolt goes through and the nut is on the top, we've just got this large washer here to help spread that force out so that when we pull on this really hard, you're not just pulling on the nut, it's going to pull on that entire washer area. So hopefully that's going to be strong enough to prevent that from coming apart like that. I also made a couple of improvements on the design. It doesn't have anything to do with the structure, but since I had to reprint it, I decided to make a few changes. On this other design, in order to mount the flight computer, we put on these little riser pieces here, just little plastic tubes. It was just easier to redesign it and print those on there already, so that's just going to make mounting the flight computer a little bit easier. Also, for the ejection charge, on this one here, we made a little change to it just before the launch day, and we ended up changing how the ejection charge was mounted in there. It really didn't get mounted in the way that I had originally anticipated, so I changed the design a little bit. Now, our ejection charges are built into these little plastic CPVC plumbing caps. We just have a little bit of black powder charge in there. On the previous design, the wire to ignite that came out the side. There was the possibility that when it exploded, some of the gases would come out that little hole and follow the wire on the side. So in the future, we're going to have the wire just simply coming out the top. This ejection charge goes into this little retaining piece here, which then threads into the nose cone base, which then threads into the nose cone. So for future launches, that's the design we're going to use, and hopefully it holds up a little bit better than this one. For the finish on the nose cone, I'm going to spray paint this red, and then I'm going to mix up a 2-part slow dry epoxy. That epoxy takes about a day or 2 to dry. So while it's drying, we're going to hang it in this direction. That will allow the excess epoxy to drip off, and we'll end up with a beautifully smooth finish on the nose cone. Now I'm going to install these 2 little launch lugs onto the side of the rocket. They're just these little plastic pieces that get screwed onto the side of the rocket that allow it to slide down onto the launch rod. It's important when you tighten these screws down that you don't over tighten it, otherwise it'll squeeze these tight and they'll get a little bit bloated in the center, which means you may not be able to slide it down onto the launch rod, or it could be tight on the launch rod, and you definitely don't want it tight. So a couple of options here. You could use a nylock insert nut that just has this little nylon piece embedded into the nut. That'll keep this from loosening up even if you don't tighten it down very tight. Now the screws that came with these launch lugs aren't long enough to go all the way through the launch lug, through my rocket, and then make it all the way through into this nylon insert nut. Now I could get longer screws, but these are the ones that came with it, and this is what I have to work with. So instead, I'm just going to take a little bit of caulking, and I'll put that on the ends of the threads so that the nut will screw onto the threads with a little bit of caulking, and that will keep these from loosening up in the future. Now because of the diameter of this body tube, I'm a little limited to where I can actually install these launch lugs. On the bottom here, we've got a lot of parts inside for holding the fins in place, so I can't get up very far. So I'll probably come up in between 2 fins about 4 inches, drill a hole through there and put the launch lug in. I'll still be able to reach in and hold that nut securely while I tighten that screw down. And at the top, I'm very limited because there's only so far I can put my arm in before I can't go in any further. I can get down to about here, maybe about 10 inches or so. So I'll do another hole straight up from that first one, about 10 inches down from the top, and install that second lug up there. And there's our 2 launch lugs installed. There's the first one down between the fins and the second one up here towards the end. Now it's important to note that if you have a launch lug up here towards the end of the rocket where the parachute is going to be inside, you don't want that screw to poke into the rocket body and become a problem where it can either snag on the parachute or on a shroud line and keep your parachute from coming out properly. So make sure that that screw isn't overly long. It shouldn't stick anywhere past the nut on the inside. For the parachute, we're going to be using our newest design parachute. This is a ripstop nylon parachute that uses paracord for the shroud lines. We have a video on our channel that shows step-by-step instructions on how to make this parachute, so I'm not going to go through that now. If you want to watch that, you can watch that separately. So, this is a 5-foot diameter parachute. Now the other component that we're going to be using in our recovery system is this small drogue parachute. It's made exactly the same way as our large parachute. It's just 12 inches in diameter. And we also use this really small paracord for the shroud lines. So it's a nice little lightweight parachute. This will be attached directly to the bottom of the nose cone. So as soon as the nose cone comes out, the drogue parachute will be the very next thing that comes out. The purpose of the drogue parachute is to ensure that we have enough wind resistance when the nose cone and the drogue parachute comes out to be able to pull out the mass of the main parachute and all its shroud lines, because there is a lot to this and we want to be sure that that gets pulled out right away. And the drogue parachute will take care of that for us. We're going to test the ejection system in 3, 2, 1. Nice. We are really happy with how beautiful this rocket came out. If you want to take a look at the launch, the link to the video is right there. If you like what we're doing, don't forget to like and subscribe. We'll see you next time. Thanks for watching.